You run your dataset loader. File 1 loaded. File 2 loading. Still loading.
4 hours later, still on file 400.
Your machine has 8 CPU cores.
7 of them are doing absolutely nothing.
Hay majas.
Episode 42, Concurrency and Multiprocessing. Threading, multiprocessing, the GIL, and concurrent.futures. Every fast Python app uses at least one of these.
Let's fix the 4-hour problem right now.
For situations where a single thread costs you hours. First, loading datasets one file at a time.
You have 8 cores and you're using exactly 1.
Second, calling APIs sequentially in a loop. While you wait for the server, your CPU sits idle. Third, single-core math in training loops.
All that matrix multiplication using 1 core by default.
Fourth, sequential web scraping is 10 times slower.
Concurrency fixes all 4 with the same Python you already know.
The GIL, Python's most talked about limitation. Think of it like a single key to one room.
Only the thread holding the key can run Python code.
So 10 threads still take turns, they don't truly run at once. For I/O work this is fine, threads mostly wait anyway. While one thread waits on a network call, another runs.
For CPU work, the GIL is a real problem.
Heavy math, transforms, data processing, threads don't help.
For CPU work, use processes, each has its own Python key.
Import threading, built right into Python, no pip needed. Create a thread by passing a target function. Pass arguments with the args parameter as a tuple.
T.start launches the thread. It begins running immediately.
Your main code keeps going at the same time. T.join blocks until that thread finishes.
Always join before your script exits, or the thread dies mid-work.
One thread for one background task. Simple and direct. Managing threads manually gets messy fast.
ThreadPoolExecutor manages a pool of threads for you.
Import it from concurrent.futures, built in since Python 3.2. Use a context manager, the pool cleans up automatically.
Executor.map applies a function to every item in a list.
All items run in parallel across your thread pool. Results come back in the original order, no sorting needed. This is just a parallel for loop, that's all it is. Max_workers controls how many threads run at once. Let's build a parallel file loader from scratch. Step 1. Collect every CSV file path with reglob. Step 2. Write a function that reads one file. Any function. One input, one output, that's all it needs.
Step 3. Open a ProcessPoolExecutor context.
Step 4. Executor.map calls the function on every file.
All files load in parallel across every core you have.
Step 5. Concat the results into one big data frame.
5 lines. Every core working. Dataset loaded.
30-second pause before processes and the comparison. If a slow dataset loader has ever cost you hours, this channel is built exactly for you. Every episode is one real Python skill explained simply. 1 subscribe keeps this series going.
2 seconds. Tap it now.
Okay. ProcessPoolExecutor and the full comparison are next. ProcessPoolExecutor, the CPU-bound version of ThreadPoolExecutor.
Each worker is a full separate Python process.
No GIL.
Every process runs truly in parallel.
The API is identical, you literally swap one class name. Split your data into chunks, 1 chunk per worker. Pass the crunch function and the chunks to executor.map.
All 8 cores do real work at the exact same time.
Merge the results with sum or pd_concat when done. Same syntax. Completely different performance ceiling. The 2 tools side by side.
ThreadPoolExecutor. IO-bound tasks.
API calls, file reads, network requests, all great with threads. The GIL doesn't matter here. Threads mostly wait anyway.
ProcessPoolExecutor. CPU-bound tasks.
Heavy math, data transforms, model preprocessing, use processes. Each process has its own Python and its own GIL. The class names are different. Everything else is identical.
1 decision. I/O or CPU. That's the whole framework.
Quick reference, which tool for which job.
Downloading files or calling APIs, ThreadPoolExecutor. Heavy math or data transforms. ProcessPoolExecutor. One background task alongside main code, threading. Thread.
Need results with individual error handling. Future.as_completed. Find the right worker count, os.cpu_count. Async web servers or async API clients. Essentio in the next episode.
Simple parallel map over any list, executor.map.
These 8 cover everything a beginner needs to start. 3 mistakes that catch everyone at least once. Mistake 1, using threads for CPU-heavy work.
The GIL means you get no speed up at all.
Feels like it should be faster. It isn't. Mistake 2, sharing state between threads without a lock.
2 threads writing the same variable causes silent corruption.
The bug appears randomly. Extremely hard to debug. Mistake 3, missing the if name equals main guard. ProcessPoolExecutor spawns child processes that import your script.
Without the guard, each child spawns more children. It never stops.
Mini project, build a parallel dataset downloader. Step 1, import requests, threading, and ThreadPoolExecutor. Step 2, write a download function for one URL. Get the file, raise_for_status, write_bytes to disk.
Step 3, open a ThreadPoolExecutor with 8 workers.
Step 4, executor.map sends all downloads at once.
8 files download at the same time instead of 1.
Build the function, pass it to the pool, let it run. That pattern works for any download or API call at scale. Your challenge. Find any folder of files on your machine. Step 1. Use ThreadPoolExecutor to read all of them at once. Step 2. Count total lines or bytes across all files.
Step 3. Time it and compare to a sequential for loop.
Bonus. Swap to ProcessPoolExecutor and compare again. The difference in speed will surprise you.
Paste your parallel script in the comments.
I reply to every single one. Let's recap what you learned today.
The GIL means only one thread runs Python at a time. Threads are for I/O files, APIs, network calls. Processes are for CPU, math, transforms, model prep.
ThreadPoolExecutor and ProcessPoolExecutor share the same API. Executor.map is just a parallel for loop. Always use the if name equals main guard with processes. Next episode, descriptors and metaclasses. How Python's own class system works under the hood. Subscribe so you don't miss it. See you tomorrow.
Concurrency and multiprocessing unlocked.
All your CPU cores are now yours to use.
4-hour dataset loads are done.
Serial API calls waiting in a queue done. Subscribe for the next episode. Drop what you're going to parallelize first in the comments. I'm Mahaz. See you in episode 43.